Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.
Hey guys, let's go over 3.53 using synthetic substitution to find zeros. I'm going to go dark mode. Okay, something I want to point out off the bat is this thing called synthetic substitution is another way of just saying we're going to be using synthetic division. Okay, so directions find all the zeros. So remember, we learned previously that zeros are positive, negative, and imaginary for each function and use them to sketch a graph. So we basically know how to find all the zeros. We know how to do that. And then this part will be new, determining the real zeros, and we already know how to figure out the type of zero. So let's go ahead and do this with me here. F of x equals x cubed plus x squared minus 7x minus 15. Okay, the first thing we need to do is determine the total number of zeros. Well, remember, the total number of zeros from the fundamental theorem of algebra is just looking at the highest degree. Look at the highest degree. Write that down so you don't forget. And in this case, the total number of zeros, well, what's our highest degree there? Is going to be 3. Okay? All right, so we're done with this part. That was step number 1. Step number 2, we need now to determine the type of zeros. And in order to do that, all we're doing is just we're going to count the number of changes. And I forgot to mention last video, this was by a mathematician, Descartes' sign change. So let me just go ahead and copy and paste this. And magic, because we're going to use that over here. Okay. Let's figure out the positives. All we have to do here is just look at the number of changes. So this is a plus, so that's change, no. There's a change here, so that's yes. And this one is no. So that means there is positive real zeros, there is only 1. Okay, so now we're going to do now the negatives. So to do this one, so we finish this one here, remember we're going to substitute in negative x. Sub negative x, right? That's just what we're doing when we say this notation. Every x value we're going to put in negative x. And then all we do from here is just go ahead and simplify it. So we get negative x cubed plus x squared plus 7x minus 15. And then we're just going to look at the changes. Is that a change there? Yes. No. And no. Whoops, can't read. That is a yes here. So there are 2 sign changes here. So for the negative real zeros, we have either 2 or comma 0. All right, we did this in the last lesson above. And then now we just need to find the imaginary zeros. And we're going to do that by making a chart. Positive, negative, imaginary, and total. So remember, our total number is 3. and see how many we might need. Okay, so our positives are from here. We have 1. I'm going to put it twice. And the reason why I'm doing twice is because the orange, for negatives, you have either 2 or 0. Now, let's go ahead and fill this out here. That means for our imaginaries, we add these. 1 plus 2 plus has to be 0. Or 1 plus 1 plus 2 equals 3. Now, I accidentally did another one, but I just want to show you why this one does not work. If you have 0 positives plus 0 negatives, that means this would have to be 3, right? But note, remember we took notes? Complex zeros come in pairs. Complex numbers in pairs. And pairs is 2s or evens. Does this make sense? So you can't have this. No. So we'll just cross it off like that. Okay? Okay, so that's what we have here. Okay, let's determine the real zeros here. This is how the book presents it, and I'll show hopefully a little more efficient way. They pick a table of values. And you basically get an output value, so let's just try 2 numbers. And if x is equal to -3, this is where we're going to use synthetic substitution or synthetic division. Okay, so I'm just going to look at my coefficients. 1, 1, -7, -15. 1, 1, -7, -15. Okay, so remember for synthetic division or synthetic substitution, the book calls it, you just bring down the first number and then you multiply. -3 times 1 is -3, and then you add down. So you get -2, multiply, 6, add down, -1. Multiply -3 times -1, you get 3, and then you'll get -12. So remember, this is the remainder. So if the remainder is -12, this remainder is not equal to 0, so therefore not a 0. You remember this? Okay, what do we have here? -12. Okay. So then I have to basically check all the single numbers out there. Now there's something the textbook didn't want to teach you guys, which I kind of noted previously. You could use something called the rational roots theorem. And you can see the abbreviations RRT. And at least it gives us some starting points. You're still kind of guessing, but for now, I'm just gonna tell you guys by graphing calculator. I'm gonna give you some steps, and we're just gonna do those. Okay. So number 1, go find yourself a. You could choose. I'm just using an iPad app, and mine is called Graph with an F in Calc 83. And what it does is it looks like a graphing calculator. So you just don't have to buy one. You can buy one. I can tell you how to find one that's pretty cheap. All right, number 2, once you get to your graphing calculator, open it up and click on y equals. I'm putting this box around it because it's like a button. Third thing you're going to do is you're going to enter the polynomial. Enter the polynomial. And I have a hint here. X squared is just faster if you just type in x times x. Okay. Number 4, we're going to click on the button second and then the button table. I'm putting boxes around these because these are each a button. And number 5, we're going to change that menu where it says to table, TBL, start. And it doesn't really matter what you start with, but put it near the origin. So I'm going to just type in -3. and then you're going to see a triangle with TBL. That means right here means delta or change, the change in the table. And what we want our change in our table, this is important. You just want it to be you want it to be 1. And then number 6, you're going to go back to your table. And what you're looking for is a reminder. This is actually from the previous lesson that you guys did in this module or chapter, is the remainder theorem. Basically, when your remainder is equal to 0, then yes, it's a factor. So that is both the factor and the remainder theorem. Okay, so that means when the remainder is not equal to 0, some other number, negative or positive, then no, not a factor. Okay, so let's go ahead and put that into our graphing calculator. Now, you could put that into Desmos. I'll see if I can figure that out with you guys. So we're going to click on y equals on the top left. Press clear on the far right next to the right arrow key. And we're going to type in the, we're going to enter the polynomial. So x to the third is right next to mine. It says alpha second is the variable x. Do not put the x on my screen. That is, oh, you don't have it. But on your graphing calculator, they'll actually have all the letters of the alphabet. Just don't use those. So x is x to the third plus x squared minus 7x minus 15. Okay, we just entered the polynomial. Now we're going to press step number 4, second table. Second table. And when it brings us to the table set. And here I just said you can start at -3. So the negative button is where it's in dark on my screen. And then table, you can start anywhere. But the change in the table, you definitely want it to be 1. Okay? And I forgot to write here. You'll see on my screen it says auto and ask. Make sure auto is highlighted because you want to automatically get the answers. Step number 6, we're going to press table. And here's a good thing. Do you guys see what we put in? X equals -3. It's already just putting it in the values for us and getting us an answer. So you see we have -12, -5, -8. And there's the one I want where it says y1 is 0. That's the remainder of 0. So that means x equals 3 is where it crosses the x-axis. So let's go back to our notes here. And -2 was -5, -8, so not factor. Let's change it to a color we haven't used. How about purple? When x was 3, then you had 0. And what this tells us is I should start right there. Let's go ahead and try that. 1, 1, -7, and -15. That's a 15. 1 times 3, 3. Add down, multiply, add, multiply, and you get 0. So that means that we already knew that this was a factor. And why is that important? Because I don't want to sit here and guess and check. I just need to know that that one works. Okay? Now, to keep going, remember this is x minus 3. That is a factor, and x equals 3 is a 0. Okay? Now, what do those coefficients mean? So, starting from the 0, you know that one is the remainder here on the far right. Then this one is the constant. This one has an x to it. And going from right to left, this one is an x squared. So think of it as this way. 0, 1, 2. Or another way of thinking about it, synthetic substitution or synthetic division basically decreased the polynomial by just an x. So we have x squared plus 4x plus 5. Okay, Now, what it's meant to be is that we keep here in orange, keep factoring. But if you try to factor that in orange, a times c is 5, b value is 4. You're thinking like 1 times 4, does that equal 5 and add to be 4? No. Can you do 5? No. And then negative. So what does that mean? It means it is prime. That just means you can't factor it. So you would actually have to use the quadratic formula. So I'm going to do it super fast if you want to do it with me, or just trust me when I get the answer. So in orange there, x equals negative b plus or minus the square root of b squared, which is 16, negative 4 times a times c, which gives us negative 20, all over 2a. And then you have negative 4 plus or minus negative 1 times square root, or positive 4 over 2. So it'll be negative 4 plus or minus 2i over 2. And then you factor out a 2. These cancel, and you're left with this answer. Negative x equals negative 2 plus or minus I. Okay, what's the big deal with that? That just means when you solve these, you have 3 solutions. X equals 3, and x equals negative 2 plus or minus I. Change my colors here. And the big idea is that this is one real. That's positive. And this one here is 2 imaginaries, because it has I in it. So now we're going to draw a quick sketch. And x equals 3. And one last value I want to get is the last value of the function, which is the y-intercept. Remember, this is an odd degree polynomial. So the arrows are going to start down and then end up. Remember, this is 2, so, and then you're going to shoot through because that multiplicity is 1. So it kind of looks like that. So let's go back to our graphing calculator and see if we have the rough sketch. You can just press graph here. And I can pinch it. And there you go. So we kind of knew that I was going to go through x equals 3, a shoot through, multiplicity of 1. And then y-intercept there is negative 15. All right, let's go over question number 16. And let's go ahead and get our chart ready. Positive, negatives, imaginaries, and total. So this is a positive, so that would be yes, yes, no. So our positives are going to be 0 or 2. Let's go ahead and put in negative x. So that would give us negative x to the third, x squared, negative 5x squared, plus 5x plus 3. And this would be a no, yes, no. So here we would have how many? Just 1. Okay, so our total, again, is here. So we have a total of 3. So 0 plus 1 plus 2 equals 3, and 2 plus 1 plus 0 equals 3. Okay. Now we can use synthetic substitution to figure that out, or we can just put that in our graphing calculator. So let's go ahead and do that. Y equals, clear, x to the third minus 5x squared plus 5x plus 3. The math operations are to the far right. We already set up our table set, so if you do this once, you don't have to do it again, and then press your table. And look at that. Same thing happened again, where, let me double check, minus 5x squared plus 5x plus 3. Yeah, and so x equals 3 is a 0. So now let's go ahead. Let's double check that. And so x equals 3, we'll just use synthetic substitution or division really quickly just to double check that. Okay, so we bring it down, multiply 3 times 1, add down, multiply, add down, multiply, add down. So that is our remainder. So we have x minus 3. Remember, you can count up. So I have x squared minus 2x minus 1. Now, this one looks like we can factor it. It looks like it. A times c is -1. B value is -2. How do I get two numbers to kind of do -1? -1? No. Can I multiply those? No. Can I put a 2 in there? No. Or 2 on that side and a 1 here? No. So you'd have to use the quadratic formula. Negative b plus or minus b squared, so it's -2 squared minus 4 times a, which is 1 times c is -1, all over 2 times a, which is 1. Remember your a, b, and c. So 2 plus or minus 4 plus 4, all over 2. Got square root of 8 here. And so 2 plus or minus radical 4 times radical 2 over 2. So this would be 2 plus or minus 2 radical 2 over 2. And then if you factor out a 2, you'll realize that our 2's here cancel, and so you're just basically left with this as your answer. So x equals 1 plus radical 2 and 1 minus radical 2. And we have this one over here, x equals 3. And so this matches our chart. Let's point out why. Because this is 3 zeros, and this one matches this one, because it has no, notice how it has 2 positives, x equals 3 and x equals 1 plus radical 2, and then the negative is the 1 minus radical 2. So if we do a quick sketch, let's do it over here. Took me a couple years to realize this, but if you draw a line and you kind of hold it, it'll make it straight. I know, changed my life. No, really, it changed my life. Okay, so y-intercept is 3. let's color code this. Our negative 0 here on the left side, 1 minus radical 2, and then the two positives, this would be 3, and I think radical 2 is equal to 1.44, so it's 1 plus, so it's like 2.44. Okay, so our graph is going to be a odd degree. So it's going to do some shoot-throughs, something like that. And art lesson, if you forget this. And then if we, you can kind of see that in our graphing calc. Graph. See? Okay. Let's go on now to question number 17. Let's count. This is a positive, so no, no, yes. So in our chart, we have 1 yes. And our total is 3. All right, let's check the negatives. So negative x for every x value. Let's go ahead and just simplify this. And then count. Yes, yes, no. So that would be 2 or 0. Okay, now I'm thinking to myself, is there a possibility that the one positive field 0 can go to the what happened? Green. Could it go to the 0? What? Sorry. No, green. That's what I want. Could it go to this 0? It could. Because 1 plus 2 plus 0 equals 3. Now, if there are remember imaginaries, you can't have two negatives. Does this make sense? I can't put a 1 here because remember this has to be even, like 0 or 2. So that one doesn't work. And this one, let's see. Does that work? Okay, that one works. And there's no other combination. You couldn't do like 0 and 3. Does that make sense? So my pen's not working. Okay, that's what we have so far. Okay. Let's go ahead and put this into the calculator. Y equals clear. Got a cubic function to the power of 3 plus 4x squared plus x minus 6. Now, if you ever get a mistake, common mistake for this one is the minus sign. If you look on the graphing calculator, there are two different ones. There's a minus sign on the yellow on the far right, and then to the left of the enter is a negative sign. I'll try using Desmos on the next example to show you guys. Table set's already done. I'm just starting at -3 and change of 1. And then I'm just going to press table. Ooh, look at all of that. Bingo, bingo, bingo. You see all the zeros there? It's telling us that x equals -3, -2, and 1 are all integers as our zeros. Previously, we had irrationals, like 1 plus right equal to in the previous problem. So you could pick either of those, and you'll get the same answer. Let me say that again. You can start with x equals -3, you can start with x equals -2, or +1. Let's try +1, and I'll show you. So 1. Now our synthetic substitution or division. 1, 4, 1, -6. 1, 4, 1, -6. Bring it down, multiply, that's a 1. Add down, multiply, add down, multiply, and this is our remainder. So you have x to the second plus 5x plus 6, and that one becomes, pay attention, x minus 1. Remember that? Now, I just want to show you really quick. All right, so if you put in, I was trying to show you, you can do another starting point, and you'll get the same answer. Watch. Bring it down, multiply, add down, multiply, that's a 1. Add down, multiply, and you get a remainder of 0. Now, this does look different. But when you factor again, so let's say we factor again here, x plus 2, x plus 3, and this one is, oops, see, I made a mistake, that should have been plus. So x plus 2, and then this would be x plus 3, x minus 1. Do you see how all of these binomials, or all these factors with parentheses are exactly the same? X plus 3, x minus 1, and x plus 2. So I wanted to show you that, you can start with different points there. Okay, and the good thing about this is, let's just say we do it from this second one. So again, multiple ways to get the zeros here. And you'll just set it equal to 0 and you get -2, x equals -3, and x equals 1. And remember, back to the previous lesson, the multiplicity here is odd. So that means they're just going to shoot through. Let's go ahead and just, so what's that thing slanted? -2, -3, x equals 1. And let's not forget our y-intercept of negative, oh no, I picked black. -6. Remember the total number of zeros, it isn't, sorry, I'm getting the color. It isn't 3, so that's an odd. The easiest odd we know is, so the first power, so starts down, ends up. And we're shooting through all of these. And looks something like that. And let's take a look. Looks just like that. See? Alright, let's try this next one. Number 18. And let's try Desmos with this one. So let's look at the positive real zeros. Yes, that's a change. No. Yes. No. So in our table, positive, negative, imaginary, total. So that means you're going to have 2, right? 2 or 0. Okay, so our total degree here is 4, fundamental theorem of algebra. And let's go ahead and try the negatives. And and this becomes x to the 4th. This will become a positive 3x to the 3rd, negative 5x squared, negative 3x plus 4. No, yes, no, yes. So there's 2 or 0. Okay, 2 or 0. Okay, so I also want to put the possibility that you could have had 2 and 0 here. Why? So 2 plus 2 plus this would have to be a 0 equals 4. 0 plus 0 plus 4, or 0 plus 2, or you could have done it the other way around, something like that. So this gives us kind of an idea. Okay, let's go ahead and put this one into our plus 4. Graphing calculator. Oh, we're going to use Desmos. So try Desmos. Okay, I'm going to do the same thing. X to the 4th. There's a quartic function. Okay, here you don't have to worry about negative signs. Minus 3x to the 3rd. I think it's just faster instead of actually putting the exponent. That's why I do that. 5x squared plus 3x. Whoops, don't need that. Plus 4. Okay, there's a bad thing. It's already telling you based off the graph what is all the answers. Okay, so we weren't supposed to look at that, but let's just say you want to do a table of values. You can just keep going up, and there you go. Let's pick x equals -1, right? Now, they could tell you, show you the graph. It actually shows you all the answers, but I was just meant to be kind of like a starting point so you don't have to start all the way. Oh, look at that. Erased all of our work. Well, you guys have the video to go back and look at that. I don't. X equals -1. Coefficients are 1, -3, -5, 3, and 4. Multiply. -1, add down. Multiply, add down. Multiply, add down. Multiply, add down. So this would be x to the 0, x to the 1st, x to the 2nd, x to the 3rd. I was counting up from right to left. And if you want to put that one in there, that's x equals ... That's x plus 1. Remember, if you just subtract, set it equal to 0, right? Okay, so then you have this. Okay, let's just try. Remember, you're like, how do I get more or factors? Well, I got 4 terms. So let's just try factoring by grouping. Let's see if it works. Because if it works, then I don't have to do anything. All right, remember we have the box. I'm using the box method, and we're trying to get the z right here, right? So x to the 3rd minus 4x squared minus x plus 4. All right, let's go this way. So I have x squared. Okay, this way you have an x in common. So this would have to be a -1 because x times -1 is -1x. That means this direction would be a plus 4. Okay, so basically what I got there is x plus 4, x squared minus 1. And then you realize you can factor this one again. Remember, that's x squared plus 0x minus 1. So a times c is -1, b value is 0, and you get 1, -1. So we have this now. And then if you solve each of these, you would get, okay, so pay attention. You have two of these. So that would be set it equal to 0. You get x equals -1. And I'm going to note multiplicity of 2. What does that mean? You guys remember? You remember. And this one. So then we do the graph. Okay, x, let's mark these. X equals -1. X equals 4. And x equals 1. And what is our y-intercept? It's 4. Okay, so we have a 4th degree polynomial, which means it's an even degree. Starts up, ends up. And remember, a -1, it's a multiplicity of 2, so that means it's a bounds or a kiss. So the goal here is that we're trying to sketch the polynomial without using the graphing calculator. So let's go and take a look. Where did I put it? Oh, here. It's not fun. You can't zoom in. I guess you could, but it goes down really far. But you get the idea there. Okay, so you can use Desmos, but I think graphing calc kind of gives you a little bit slower, kind of just not just the answer. Okay, question number 19. Let's count. So this is a plus. So sign change, no. No. Yes. So that means in my chart, positive, negative, imaginary, total, I have 1 positive. Total is 3. Let's go ahead and put in the negative. Just simplify here. Count the number of changes. Yes. Yes. No. So we have 2. Or 0. So that positive, and then 1 plus 2 plus 0 equals 3, or 1 plus 0 plus 2 equals 3. Okay, so again, you can just guess. You can use the rational roots theorem, which I haven't taught you guys, or we can just punch into the calculator to get us a little hint. A little hint. X to the third. I'm going to make sure I'm typing the right one. Go back to graph and calc. Y equals clear. X to the third plus 7x squared plus 4x minus 12. Okay, so I got table set's already done, so just press table, and then we have -2, 0. That means x equals -2 is a 0, and x equals 1 is a 0. Let's do x equals 1. Please don't erase. Oh, I erased. Maybe I have to press save before I do that. Okay, what did we say? There were 2, 0, 1, 0, 2. Okay, so x equals 1, and my coefficients are 1, 7, 4, -12. 1, 7, 4, -12. Multiply, add down, multiply, add down, multiply, add down. So your remainder is 0. This is x to 0, x to the first, x to the second. And so you have x minus 1, x squared plus 8x plus 12. And it looks like it's factorable. I think a times c, b value is 8, 4 and 3, 6 and 2. And set those equal to 0, and you'll get x equals 1, x equals negative 6, and x equals negative 2. And what I wanted to point out are, okay, the blue, so this one is here, this one is here, and the orange one is here. So we're using this one. See how it's working? All right, let's go ahead and just draw a quick graph. X equals 1, negative 6, blue negative 2, and the y-intercept. What color did I use? Blue. Negative 12. Alright, let's go ahead and sketch this. Starts down, ends up. Shoot through, comes down. And see if we were correct. Pretty good, right? All right, question number 20. Let's count the positive real zeros. This is a plus, so yes, no, no, no. That means in my table, positives we have 1. Okay, let's go ahead and figure out the negative. Substitute in a negative x, and then the last lesson. So simplify negative x third, positive 3x to third, that would be x squared, negative 3x squared, positive 75x minus 700. Yes, no, yes. What? Yes, 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 yes. Okay, so we have 4 negatives. You have 4, or you can have, let's see. Okay. Do you see why I'm going to erase the 4 in that position? Okay, 4, 2, or 0. Our total is 4. And then our imaginaries. Okay, so I know this one doesn't work. Pause and think a second why this first column doesn't work. Because I would have to input 1. And remember, the imaginaries have to be in pairs or evens. So 0 to 4. So that one does not work. Okay. If you did it this way, this one would work. And then is it possible you have this one? Nope, because that's an odd. How about if you did 0, can you do 1, this number? I just did that. Oh, can you do this? Does that one match? Yes, that one does match. So we can have those combinations. Okay? Alright, let's go ahead and put this into the graphing calculator to get us a starting point. The goal is not to actually get all of the zeros. It's meant to be done by factoring x to the third fourth minus 3x to the third minus 3x squared minus 75x minus 700. I already have under table set starting. I basically want change of 1 near the origin. And then you'll notice none of my numbers. So you can go up. Oh, good gamble. All right. X equals -4. X equals X equals -4. 1, -3, -3, -75, and -700. Multiply, bring down, or add 28, add down, -100, -175. It's going to be a positive. 0 extra 2. 28 plus 2 is 30, so 0 extra 3 and 700. Whoop, whoop. Okay. This means you have x to 0, x to the first, x to the second, x to the third. Let's see what we got. X plus 4 . Do you think we can factor here? Remember, 4 terms, you gotta try it. Let's try it. X to the third minus 7x squared. I think it's gonna do it. I missed it right there. X minus 175. X squared. 25. I'm gonna guess positive. Yeah. Okay, going in this direction is x. In this direction, minus 7. Okay, so we have x plus 4. Then in blue, we just factored this x minus 7, x squared plus 25. Okay, from here, you can do a couple of ways. You can use the quadratic formula, just put it in there, it's going to be long. Hopefully you recognize that you have something that looks like this. But I'm going to use a method we haven't used in a while. It's called the square root method. Or the radical method. And basically you just solve for x. Subtract 25 from both sides. Get x squared equals negative 25. Big idea from this past year, if I take the square root here, it has to be plus or minus. You get x equals square root of 25 is square root of -1 times 25. Square root of -1 is what? And square root of 25 is 5. So this will give me 2 imaginaries and x minus 7. Maybe your combination's wrong. X equals -4. That's a negative. And x equals 7. Uh-oh. Let's see. Let's sketch this out. Okay, this one is an imaginary, so we don't even put that in there. And it's to the 4th degree. So we're going to start up and up like this. Negative 700 is my y-intercept. And I have x equals 7 and x equals negative 4. And they're all shoot-throughs. So all right, that's my crazy looking graph. And let's take a look. Graph, graph, graph. Okay, here it is. And my crazy looking graph is not too far from this one, right? Okay, what I wanted to point out is that you have one that's positive, one that is negative. 1, 2, 3, 4, 4, 2, or 0. Negative 700, negative 4, 7, 5, negative 5. Well, I guess we could have gone 1, 1, which we did, and 2. So you can't have, the only thing I make sure is the imaginary is going zeros. Okay, last one, let's count our changes. Yes, 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 yes. So positives, you have 4. Let's go ahead and put in negative x. It's positive. Negative 8x to the 3rd plus 20x squared plus 32x plus 64. Yes, yes, no, no. So negatives, we can have 2 or 0. Let's just try putting that in for now. Total is the highest degree. And then imaginaries would have to work like this. 4 plus 0 plus 0 equals 2. 2 plus 0 plus 2, or 0, 2 plus 2. Okay? So these are all the combinations we have. Let's go ahead and put that into our graphing calculator to give us some hints. And we're basically using the factor and remainder theorem to help us figure out some starting clues. Now, you could use guess and check. Not fun. Minus 32x plus 64. We already have our table set. And the big idea there is you just want it to change by 1. So I'm going to go to my table, and then let's go down. There it is, 4, 0. So x equals 4, then your output is 0, which means it's a remainder. So let's put in x equals 4. Use synthetic substitution or synthetic division. So 1, negative 8, 20, negative 32, 64. Bring it down, multiply these numbers, add down, multiply, add down, multiply, multiply, you get negative 64, which gives you a remainder of 0. X to the 0, x to the 1, x to the 2, x to the 3. So this would give us x minus 4, x to the third minus 4x squared, plus 4x minus 16. Now again, you have 4 terms here, so I'm just going to give it a try and see if we can get this done by factoring, by grouping. X to the third minus 4x squared plus 4x minus 16. Okay, this way they have an x squared in common. This one's an x. Okay, that's an easy one. I think this one's going to be a minus 4. Because negative 4 times x squared is negative 4x squared. And that means this one will have to be a minus 4. So we have x squared minus 4, x minus 4. And then this one, you'll notice, is just going to be x plus 2, x minus 2. You can use that by factoring your b-value 0. And then this one, I'm going to put x minus 4 squared. That's a multiplicity of 2. So x equals 4 with a multiplicity of 2. This one means x equals 2. And the last one there, what color have I used? Blue. X equals negative 2. Alright, let's do a quick sketch. Okay, x equals 4, x equals 2, x equals a negative 2, and let's go get our y-intercept. Plus 64. And this is to the highest degree is a 4, so it's an even. So remember, we have to do a shoot through at x equals 4. So shoot, oh, I'm sorry, bounce there. It's 4th degree. X equals negative 2. Sure, it's a positive 64. I'm a little stumped here. Because that would have been the bounce, right? Let's take a look. Oh no, I forgot to save. Okay, you have 4 and no other ones. Okay, so that means I think we made a mistake. Darn race. Thank goodness. Okay, x equals 4. Two and negative 2. Oh, see my mistake. It has to be a positive 4 here. 4 times x is 4x squared, so that makes sense. X squared plus 4. So this one is x squared plus 4. And then when you do that one, okay, that one makes sense. When you solve that one, you'll get subtract 4, take the square root, you're going to get negative 1 times square root of 4, which is x equals plus or minus 2i. And so this graph doesn't Starting up here, right? That's my crazy graph, my rough sketch. But the big idea there is that 4, you just bounce off. Okay? Hopefully that was helpful for you. We'll see you guys later. Bye-bye.
Yo. 2 plus 2 is 4, minus 1, that's 3 quick maths. Everyday man's in the class, doing problems. See that problem board, that problem is easy, thanks to Mr. Ing.